Okay, so today's notes are on arithmetic series. It's section 9.4, and our content objective is to define arithmetic series and find their sums, and our language objective is to use the correct terminology to describe arithmetic series. So first thing, I've already written it down, a series is the sum of a sequence. So simply put, series is when you take all the terms in your list, add them all up. That's your series. So if we had the sequence, so for example, if we had the sequence 3, 5, 7, 9, so on, then the series version of that would be 3 plus 5 plus 7 plus 9 plus so on and so forth. So it's just when you take the list and then instead of just listing them, you're adding them up, and that is a series. So a series can be finite, which means it has a first and last term. So finite, it finishes, it has an end. Well, there are also infinite series or sequences. So these finite and infinite can apply to both series and sequences. It just means has an end, or if it's finite, or continues without end. If it's infinite. So these are words you've probably seen anyways, but just so you know, they can be used to describe sequences and series as well. So today we're focusing specifically on arithmetic series. So a sum of a finite arithmetic series. So the reason it has to be finite is because for arithmetic series, if they were infinite, you'd be continuing to add larger and larger or more negative numbers if you're subtracting, but you'd continue to add numbers infinitely if it were an infinite sequence, which means it would not have a sum, or its sum would also be infinite. So we can only find the sum of finite arithmetic series. But the formula for that will be Sn equals n over 2 times a1 plus an. Let's define these variables so we know how to use them. Sn, first of all, is the sum to the nth term. So it's the sum if you added up all the terms to the nth term. N, similarly, is the term number. This is the same n we've been working with previously, the placement in the list. So it tells you what place you are adding up to. So in this context, it will be the last term number. So if you had 7 terms in your list, n would be 7 because it'd be the last place value in the list. A1 is just like before, our first term value. So it's the actual number that's first in our list. If we're looking at this example up here, it would be 3. An is going to be the value of the nth term. So if we pretended that this list stopped here, an would be 9 because it's the value of the last term, but n would be 4 because it's the 4th term in the list. So in this context, similarly, it's the last term value. All right, so that's our formula. Now let's do an example to practice using it. So I'm going to flip the page. While I write this example, if you can send me an email and tell me you're listening, that would be great. So again, send me an email. Let me know you are listening to these notes. So our example asks, what is the sum of the even integers from 2 to 100? So if we do that, first thing we need to do, step 1, is define our variables. So I'll rewrite our formula so we can have it in front of us. It's Sn equals n over 2 a1 plus an. And first thing, let's define n, because this one's a little bit different. I'll show you later how to solve for n if it's not given, but in this case, we can actually solve for it through reasoning. So if we're talking about the even integers from 2 to 100, we know it's going to be every other number from 2 to 100, so that's going to be 100 over 2, or 50. So in this case, we know our n value is 50. Just we can reason through it, but I'll again show you examples of how to solve for n if you're not sure how to do that. Then let's also define our first term value. So a1 we know is 2, and a50 or an is 100 because it's from 2 to 100. So I know all the variables in here, so I can go ahead and substitute those values into my formula and then evaluate. So if I substitute, I have S50 equals 50 over 2 times 2 plus 100, and that becomes 25 times 102, or 2,550. So the sum of the even integers from 2 to 100 is 2,550. All right, so there's also some more notation I want to talk about with you guys. So we've practiced using the formula, we know how to do that. There is other notations you might see to represent series or sums, and one example is the Greek letter sigma, the capital sigma, and this represents a sum as well. So the other part of this, we'll do an example of how to use this notationally. If you had, say, these numbers here represent your term limit, or your, not term limits, your limits and your series. So this is the first n value. This would be the last n value. And then what would be written next to the sigma is your sequence equation. So what this notation is telling you is you're adding up all the terms from the first term to the 70th term for the sequence that's represented by that formula. So if you plugged in all the numbers for n from 1 to 70 into this equation and then added up all those values, you would get the sum for this. Of course, there's easier ways to do that. So let's actually go through an example or further this example and ask, what is the sum of that series? So what is the sum of the series from n equals 1 to 70 for 5n plus 3? Okay, question mark. So the first thing we're going to do is determine or define our variables again. Or sorry, before we do that, we need to determine, because we can't define our variables, we don't know our a1 and a70 values, so we're going to determine those values first and foremost. So we're going to determine a1 and a70. So I'm going to use my sequence formula to do that. So they gave me this here. So I'm going to say a1 is equal to 5 times 1 plus 3, because again, my n value, my subscript tells me what I'm plugging in for n, which gives us 8. A70 is going to be 5 times 70 plus 3, which is 353. Now I can substitute into my formula. Also, I know this, backing up for a second, I know this is arithmetic because I'm multiplying and adding. I'm not raising to a power. So I'm going to substitute into my formula. And I have Sn equals n over 2, a1 plus an. And if I plug that in, I get S70 equals 70 over 2 times 8 plus 353. If I evaluate that, calculate it out, I get S70 equals 12,635. So my last step was to evaluate. Okay, so that's my answer for that one. Last thing, I told you I would show you how to solve for n, so I'm going to flip the page and do that. So last example, what if you don't know your last n value? So we're going to do an example. And I'm going to ask, what is the summation for the series? 7 plus 11 plus 15 plus ... plus 203 plus 207. So again, I have my sequence or my series, but I'm not sure what, I know my term values, but I don't know what term number 207 is. So before I dive into this, I first want to verify that the series is arithmetic. And again, it is, if I find my common difference, I see that it is 4 each time. So I do know it's arithmetic, and D is equal to 4. Now I'm going to, step 2, write the sequence equation. Again, sequence, not series. So I know my sequence equation for an arithmetic sequence is an equals a1 plus n minus 1 times d. I already know my d value is 4, and if I look here, I can say my a1 value is 7. So then I just need to solve, I'm trying to figure out my n value again, because I need to know n in order to use my summation formula. Lucky for me, I know the value of the nth term, or the last term in the sequence, so I'm going to substitute the last term value for an, and then solve for n. So I plug that in, I have 207 equals 7 plus, n minus 1 times 4. So again, I just plugged in my a1 value, and then I said an is going to be 207. So if I plug that in, solve it out, I subtract 7, I get 200 equals n minus 1 times 4. I divide by 4, and I get 50 equals n minus 1. So 51 is equal to n. Now I know all the values I need to know to substitute into my summation equation. So again, I'll rewrite that for you so you have it in front of you. And now I'm just substituting those values. So I can say S of 51 is equal to 51 over 2 times 7 plus 207. If I calculate that out, I get S51 is equal to 5,457. So my last step again was to evaluate, and that is all. So again, the big step is you solve for n by plugging into your sequence equation. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.